Hello, I'm the awesome tutor. Today we're going to be looking at arithmetic series from C1. So an arithmetic series is a sequence that increases by a common amount each time. So this sequence is arithmetic because it increases by 2 each time. It has a common difference. This sequence is not arithmetic because it does not have a common difference. It is actually geometric, which you will learn about in C2. This sequence is arithmetic because it has a common difference. It increases by -5 each time. So the nth term. The nth term is calculated by the formula a plus n minus 1d, which you will be given in your exam. A is the first term of the sequence, n is the nth term, so the number of the term you want to find. D is the common difference, so by how much it increases or decreases by each term. So here's an example. The first term is 3. The common difference is 2 because it increases by 2 each time. So let's find the 100th term of this sequence using the formula. So we just substitute the value of a, the value of n, and the value of d, and we get the 100th term is 201. Sometimes they give you their own formula for working out the nth term. So you use that instead of a plus n minus 1d. So for this example, let's work out the third term. We substitute the value n is equal to 3 into the formula. And we get the third term is equal to 13. Now sometimes they give you the value of the nth term and you have to work out what number it is, what position it is in the sequence. What is the value of n that gives you 319? So you just create an equation and you solve for n. N is 54 in this case. So proving a plus n minus 1d. So if you write out the sequence in full, you have the first term. The second term, you add the common difference. For the third term, you add it again. The fourth term, you add it again, and so on and so on and so on. And we can see the relationship between the number of the term and its value is that the coefficient of d is always 1 less than the number of the term. So for the second term, okay, the coefficient of d is 1. 1 is 1 less than 2. For the fifth term, the coefficient of d is 4, which is 1 less than 5. So we can derive the formula a plus n minus 1 d. Now the sum of an arithmetic series is given by these formulas. They will be given to you in your formula booklet for C1. They might ask you in the exam to prove this formula, and you need to know how to do it. So if we write out the sum in full, the first thing we do is we reverse it. So we have the last and second last first, and then all the way up to the first term. Then we add these two sequences. So we add s of n and s of n, which is going to give us 2s of n, which is going to be 2a plus n minus 1d for every single term. Why? Well, let's look at the first term. A plus n minus 1d. That's going to give you 2a plus n minus 1d. Let's look at the second term. A plus d plus a plus n minus 2d. Well, a plus a gives you 2a. D plus minus 2d gives you minus 1d. And that's going to be the same for every single term. 2a plus n minus 1d. Let me give you an example. So 1 plus 2 plus 3 all the way up to 100. We reverse it, and then we add them together. 1 plus 100 is 101. 2 plus 99 is 101. 3 plus 98 is 101, and so on and so on and so on. So the value of these terms of 2s of n is always 2a plus n minus 1d. So in that case, we say we have n lots of 2a plus n minus 1d. And then we just rearrange and solve for s of n. We get n over 2, 2a plus n minus 1d. And what about n over 2a plus L? L is the last term that you add to find the sum. So L is going to be worked out, the value of L is going to be worked out by using the formula a plus n minus 1d. So you just substitute that into n over 2a plus L, which gives you this. And you simplify it, you go back to the original formula, n over 2, 2a plus n minus 1d. Now to prove that the value of n for L is the same as the value of n for the actual sum, I'm going to give you an example. So we want to find the sum up to 100 terms. Okay? And the value of L is going to be worked out with the formula a plus n minus 1d. The L is going to be the 100th term. And we want to find the sum up to 100 terms. So therefore, 100 is the same as 100. The value of n for L is the same as the value for n of the actual sum. So we can substitute L into n over 2a plus L. Now, let's actually practice using this formula. So an imperial officer receives a salary of 20,000 credits. He receives an annual wage rise of 500 credits at the end of every year until his salary reaches a maximum of 25,000 credits. What is the total amount earned in the first 10 years serving the empire? So, we use the formula S of n is equal to n over 2, 2a plus n minus 1d. In this case, we're finding the sum up to 10 terms because it's 10 years. So you substitute in the values of a is 20,000, and d is 500. You get S of 10 is 222,500. So the total amount he earns in the period of 10 years is 222,500 credits. Now what about the total amount he earns over 15 years? Now you have to be careful because here it says he receives a wage rise of 500 at the end of every year until his salary reaches a maximum of 25,000. So when it reaches that maximum of 25,000, it's no longer going to increase by 500. So this formula is not going to work when it reaches that point. So let's find that point when it stops increasing. We use a plus n minus 1d to find what year it stops increasing using the value of 25,000 as the nth term, and we solve for n. So we find out that it increases by 500 up to 11 years. Then it stays the same. And for this period when it stays the same, we have 4 more years to go. So, first of all, let's find how much he earns in that 11 years using the formula, which is 247,500. So he has 4 more years to go to get to 15 years, but there is no increase in these 4 years. So what is the maximum? 25,000. That's how much he's going to get for each of those 4 years. Just times that by 4, and we just add it on to the total he earned for those 11 years. And that gives us 347,500 credits. So, now an actual exam question modified in a Star Warsy way. Each year, the Emperor invests into the Death Star. In the first year, he invests 5 million credits. His investments then increase by 2 million credits each year. How much does the Emperor invest into the Death Star in the 10th year? So we use the formula a plus n minus 1d. A is going to be 5 million credits, that's how much it starts off with. And then D is going to be the common difference, how much increases by each term each year. So 2 million credits, that is D. We substitute in those values. N is 10 because it's 10 years, the 10th year. And we get the 10th term is 23 million, and so the answer is 23 million credits. The Emperor invests into the Death Star for n years until he has invested a total, keyword total, of 672 million credits. show that n squared plus 4n minus 24 times 28 is equal to 0. So for this, we use the formula S of n is equal to n over 2 2a plus n minus 1d, because this is working out how much he invested in total. So we use the sum formula. We substitute in values for a and for d, which we worked out. N is what we're trying to find. So we know that whatever value of n we have, it must give us the answer 672 million. Okay, it must give us that sum, as stated in the question. We just have to find out what value of n gives us that. So we put everything into the formula, we simplify, we rearrange, and I have missed out those steps because we're using big numbers and I just can't be bothered. Okay, so you end up with n squared plus 4n minus 672 is equal to 0. Minus 672 can be written as minus 24 times 28, and that's how you show that n squared plus 4n minus 24 times 28 is equal to 0. Now, hence find the number of years that the Emperor invests into the Death Star. So the second part of the question really helped us, because we already have n squared plus 4n minus 24 times 28 to use to find the number of years the Emperor invests into the Death Star. So we just factorize it. Okay, it kind of already gives you the factors, minus 24 times 28, which is really nice. Okay, but it's not always going to do that. So you have n is 24 and n is negative 28. We can't have negative years, so therefore the answer is 24 years. Now, even if you could not do the second part of the question, you can still do the third part, because in the second part of the question, it gave you n squared plus 4n minus 24 times 28, which you could have used easily in the third part of the question. Alright, this has been the Awesome Tutor. Bye.